Welcome to Spring Lib.
So here we have three bases: ammonia, whose concentration is zero point 0.6 molar. Then we have KOH, or potassium hydroxide, which is 0.15 molar. And we have barium hydroxide, which is zero point 0.1 molar. Now we have to find out which of these bases are most basic. So ammonia is a weak base which will interact with water to slightly dissolve and form NH4 plus and OH minus. But as we said that it is a weak base, it will be very slightly dissolve or slightly dissociate to form a very small amount of hydroxide ions. That means this will not be our most basic solution. Then if we go for the KOH will, since it's a strong base, it will be completely dissociate to give us potassium ion and hydroxide ion. So if the concentration of the KOH is 0.15 or 15 molar, that means, or since it's 0.15 mole per liter or 0.15 molar, then the concentration of the hydroxide will be also 0.15 molar. That means it will create or produce this mole of hydroxide ion, or this molar hydroxide ion, as the concentration. And finally, if we look for the barium hydroxide, it will be dissociated into barium ion and hydroxide ion. And this is also a strong base. That means it will be also dissociated completely into its ions. And that means, so from this case, if we have zero point 0.1 molar barium hydroxide, that means it will also it will produce 2 2 into zero point 0.1 molar. That means zero point 0.2 molar hydroxide ion. Since 1 molar barium hydroxide is producing 2 hydroxide ion, that means zero point 0.1 molar barium hydroxide will produce zero point 0.2 molar hydroxide ion. And from here we can see that in case of the barium hydroxide, the concentration of the hydroxide ion, which basically um, which, which is the factor on which the basicity of a solution depends, and higher the concentration of the hydroxide ion is, more basic a solution is. And since the hydroxide ion concentration in this case is the highest, that means barium hydroxide will be our most basic solution here.